Hi, good morning dear students. So now last class alli velocity in two dimension with the acceleration in two dimension and a projectile motion. So istu concepts ಬಗ್ಗೆ discuss ಮಾಡಿದ್ವಿ and also we have to prove the trajectory of projectile is parabola. So istu ನಾವು ಏನು ಮಾಡಿದ್ವಿ last class alli discuss ಮಾಡಿದ್ವಿ. So let me continue the topic. So today we shall discuss about the expression for the maximum height, time of flight and the range of the projectile. So idr ಬಗ್ಗೆ discuss ಮಾಡ್ತಾ ಹೋಗೋಣ. Now let's see the maximum height, time of flight, and range of projectile. So see here we know that about the projectile motion. So what is meant by projectile motion? So here I am considering the projectile or an object is moving in two dimensions. So let us consider an object moving with the initial velocity, that is v0, that is moving with the initial velocity and making an angle theta with the horizontal direction. So ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಒಂದು ಬಾಡಿನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗ್ತಾ ಇದೆ, that is moving from the initial position ಅಥವಾ initial point O, it makes an angle theta with the horizontal direction. ಅಂದ್ರೆ horizontal, so a direction of projection ಏನಾಗ್ತದೆ, angle theta create ಆಗ್ತದೆ. Here the velocity v0 is divided into two rectangular components and one is horizontal component of velocity and another one is vertical component of velocity. Now let's see the horizontal component of velocity is horizontal component of velocity, that is Vx is equal to v0 cos theta. So initial velocity na two rectangular components agi divide ಮಾಡ್ತಿದ್ರೆ, ಒಂದು horizontal component of velocity, that is Vx is equal to v0 cos theta and another one is the vertical component of velocity. Vertical component of velocity, that is Vy is equal to v0 sin theta. So here see the horizontal component of velocity remains constant. So constant ಆಗಿರುತ್ತೆ horizontal component. ಯಾಕೆ? There is no force acting over the horizontal direction. ಯಾವುದೇ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ horizontal component of velocity ಏನಾಗುತ್ತೆ, it remains constant. But vertical component of velocity keeps going, changes with respect to time. ಯಾಕೆ? The force of attraction is the gravitational force always acting on the vertical component of velocity. So that's why the vertical component of velocity is changes with respect to time. So now let's see the maximum height, time of flight and the range of projectiles. Now see the first one. So that is the time taken to reach maximum height. Time taken to reach maximum height, that is the time of flight. What is meant by time of flight? Here see the figure. So the object initial position in the point P reach ಆಗೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅದನ್ನ ನಾವು ಟೈಮ್ ಆಫ್ ಅಸೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ taken as the time of ascent. Again, ಈ ಪಾಯಿಂಟ್ P ಇಂದ again ground ಗೆ ರೀಚ್ ಆಗೋದಕ್ಕೆ ತಗೊಳ್ಳೋಂಥ ಟೈಮ್ನ ನಾವು ಟೈಮ್ ಆಫ್ ಡಿಸೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. The time taken to reach the maximum height. The time taken to reach the maximum height. Maximum height is called time of ascent. Is called time of ascent. So here in the initial position this is the maximum height reached by the object. So the point P. So the maximum height reach ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅದನ್ನ ನಾವು ಟೈಮ್ ಆಫ್ ಅಸೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಈ ಪಾಯಿಂಟ್ ಇಂದ ಗ್ರೌಂಡ್ ಗೆ ರೀಚ್ ಆಗೋದಕ್ಕೆ ತಗೊಳ್ಳೋಂಥ ಟೈಮ್ ನ ನಾವು ಟೈಮ್ ಆಫ್ ಡಿಸೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. The time taken by the projectile taken to reach the ground from the maximum height. From the maximum height is called time of descent. ಕೆಳಗಡೆ ಬರೋದಕ್ಕೆ time of descent, ಮೇಲ್ಗಡೆ ಹೋಗೋದಕ್ಕೆ time of ascent. Now the time of flight. What is meant by time of flight? The total time taken to reach the ground from the initial point. See, this is the initial point, this is the final point. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಮತ್ತೆ ಹೇಗೆ ರೀಚ್ ಆಗುತ್ತೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ? The time of ascent plus the time of descent is called the time of flight. So now total time ನೇ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Time of flight. So see, the total time taken by the projectile to reach the ground from the initial point, from the initial point is called time of flight. Time of flight. So what is meant by time of flight? The total time taken by the projectile to reach the ground from the initial point is called time of flight. So ಮೇಲಕ್ಕೆ ಹೋಗೋದಕ್ಕೆ ತಗೊಳ್ಳೋಂಥ ಟೈಮನ್ನ ನಾವು time of ascent ಅಂತ ಹೇಳ್ತೀವಿ. Then ಕೆಳಗಡೆ ಬರೋದಕ್ಕೆ from the maximum height ಅದನ್ನ time of descent. So time of ascent plus time of descent ಅನ್ನ ನಾವು time of flight ಅಂತ ಹೇಳ್ತೀವಿ. So what is the definition of time of flight? It is the total time taken by the projectile to reach the ground from the initial point is called the time of flight. So now let's see the expression for the time of flight. So time of flight we have the equation. So how to derive the equation? So let's see the expression for the time of flight. Now let's see the expression for the time of flight. Time of flight. So let T be the time taken by the projectile to reach the maximum height. That is the time of ascent. See here for vertical motion. So here we can take the vertical component of velocity, that is Vy is equal to V0 sin theta. So this is the initial velocity. Then the final velocity, that is Vy becomes 0. Final velocity is 0. ಯಾಕೆ? So ಇಲ್ಲಿ maximum height reach ಆಗೋಕೆ ನಮಗೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅಂತ ನೋಡ್ತಾ ಇದ್ದೀವಿ from the initial position. So maximum height reach ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ that the velocity becomes 0. Velocity maximum height is 0 ಅಂದ್ರೆ ಮಾತ್ರ ಏನಾಗುತ್ತೆ ಕೆಳಗಡೆ ಬರುತ್ತೆ. So that's why the final velocity becomes 0. Then the acceleration A is equal to minus g. Now let's see by using the one of the kinematic equation, that is V is equal to V naught plus AT. So V is the final velocity, V naught is the initial velocity, A is the acceleration, T is the time taken. Now final velocity of the projectile. This is the final velocity. So maximum height reach ಆಗಬೇಕು. Maximum height reach ಆದಾಗ ಮಾತ್ರ velocity ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. Velocity 0 ಆದಾಗಲೇ ಮತ್ತೆ ಏನಾದರೂ ಏನಾಗುತ್ತೆ ಕೆಳಗಡೆ ಬರುತ್ತೆ. So this final velocity is 0. That is equal to V naught be the initial velocity. So we are taken the vertical component of velocity, that is V naught sin theta. V naught sin theta plus, so ಇಲ್ಲಿ acceleration ಇದೆ, A is equal to minus g into t. Then so 0 is equal to V naught sin theta minus g into t. So ನನಗೆ ಬೇಕಾಗಿರೋದು ಟೈಮ್ ಆಗಿರೋದ್ರಿಂದ so ಈ ಕಡೆ ಕೊಡ್ತೀವಿ t into g is equal to V naught sin theta, then t is equal to V naught sin theta divided by g. So this is the time of asset. T is equal to V naught sin theta divided by g. Here namin ಬೇಕಾಗಿರೋದು so time of flight. Here the time taken by the projectile to reach the maximum height, that is that our time of ascent is equal to the time of descent. ಮೇಲಕ್ಕೆ ಹೋಗೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೋ ಕೆಳಗಡೆ ಬರಬೇಕು ಅಷ್ಟೇ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಸೊ ನಮಗೆ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಅಂದರೆ ಟೈಮ್ ಆಫ್ ಅಸೆಂಟ್ ಪ್ಲಸ್ ಟೈಮ್ ಆಫ್ ಡಿಸೆಂಟ್ ದನ್ the total time taken by the projectile, that is the time of flight. T is f. T f represents the time of flight. So time of flight is equal to 2 into t. What is that 2 into t? T is the time of ascent. So we know that the time of ascent is equal to time of descent. ನಮಗೆ ಬೇಕಾಗಿರೋದು ಟೋಟಲ್ ಟೈಮ್. ಅದಕ್ಕೋಸ್ಕರ ಏನು ಮಾಡ್ತೀವಿ 2 into t. Then T f is equal to 2 V naught sin theta divided by g. So this is the expression for the time of flight. T f is equal to 2 V naught sin theta divided by g. V naught is the initial velocity, g be the acceleration due to gravity. So now let's see the second one, that is the height of the projectile, the maximum height of the projectile. Second one, height of the projectile. So now let's see the expression for the height of the projectile. The maximum height reached by the projectile from the ground is called the height of the projectile. Let's see h be the height of the projectile. Height of the projectile. See, figure so this is the height of the projectile. So now we ಏನು ಮಾಡಬೇಕು, so ಆ h ನ equation ನ ಕಂಡುಹಿಡಿಯಬೇಕು. So that is the maximum height of the projectile. See, for vertical motion, so we know that the velocity v is equal to, for vertical motion, v naught sin theta. So vertical component of velocity is togoltidivi, that's why vy is equal to v naught sin theta, and the final velocity becomes 0. ಯಾಕೆ? maximum height reach ಆದ್ಮೇಲೆ final velocity ಏನಾಗುತ್ತೆ 0. Then a is equal to minus reach the maximum height, that is the time of ascent. So we know that. So now we derive that is the time of ascent. T is equal to V naught sin theta divided by G. So we know that the equation of motion, that is x is equal to V naught T plus of AT square. So x is the maximum height reached by the projectile. So we can add h and the button. So here V naught is the initial velocity. So initial velocity vertical component of velocity that is V naught sin theta into t. So now we go to the time of ascent is V naught sin theta divided by G plus 1 by 2 A. So for vertical motion A is equal to minus, that is acceleration due to gravity. That again T there. So that is V naught sin theta divided by G whole square. So that h is equal to, so V naught is V naught is, so V naught ಏನಾಗುತ್ತೆ V naught square sin theta ಇದೆ, sin theta into sin theta, that is sin square theta divided by G. So plus into minus ಇದೆ minus ಇಲ್ಲಿ square V naught square sin theta is whole square ಇದೆ sin theta whole square sin square theta divided by ಕೆಳಗಡೆ G square ಇದೆ, ಇಲ್ಲಿ G ಇದೆ. So 1 G get cancelled ಆದರೆ ಉಳಿದು remaining 1 G 2 into G 1 by 2 ಇದೆ. So ಇಲ್ಲಿ G ಇದೆ, so ಇಲ್ಲಿ square ಇದೆ G square 1 G get cancelled ಆದರೆ remaining 1 G ಉಳಿದು 2 into G. ಇಲ್ಲಿ V naught square sin square theta divided by G minus 1 by 2 V naught square sin square theta divided by G. So ಇಲ್ಲಿ ಕಾಮನ್ ಏನಿದೆ V naught square sin square theta divided by G ಕಾಮನ್ ಇದೆ, that x is equal to, so h is equal to, so ಕಾಮನ್ ತಗೊಳ್ತೀವಿ ಯಾವುದು V naught square sin square theta divided by G ಕಾಮನ್ ಇದೆ, V naught square sin square theta divided by G ಕಾಮನ್ ಇದೆ. So first term ಅಲ್ಲಿ ಎಲ್ಲ ಕಾಮನ್ ತಗೊಂಡು ಉಳಿದಿದ್ದು 1 minus 1 by 2 ಇದೆ ರಿಮೈನ್. So 1 minus 1 by 2 is 1 by 2. Then height h is equal to V naught square sin square theta divided by 2G. So this is the expression for the maximum height of the projectile, that is h is equal to V naught square sin square theta divided by 2G. So 1 minus 1 by 2 ಅಂದರೆ 1 by 2. So denominator ಅಲ್ಲಿ 2 multiply, h is equal to V naught square sin square theta divided by 2G. So this is the expression for the maximum height of the projectile. So next to see the range of the projectile. Range of the projectile. So now what is meant by range of projectile? See, the horizontal distance covered by the projectile from the initial position. So this is the initial position, this is the final position. This horizontal distance is called the range of the projectile. So horizontal distance na ನಾವು ಏನು ಕರೀತೀವಿ range ಅಂತ ಕರೀತೀವಿ. The horizontal distance covered by the projectile from the initial position is called the range of the projectile. The horizontal distance position is called range of projectile. Range of projectile. So the range of projectile is represented by the letter R. So horizontal distance from initial position is the range of projectile. Now let's see the expression for the range of projectile. So now let's see. We know that the velocity. So now velocity andre gottu. So velocity is the rate of change of displacement. That is displacement by time taken. Displacement by time taken. So that which implies v is equal to x divided by t. So now we take the range of projectile, that is the distance. Here the time taken means the time of flight, the time of ascent plus the time of descent. Okay, two-dimensional motion ಆಗಿರೋದ್ರಿಂದ we have to take the time of flight. Here the velocity, that is the horizontal component of velocity. ಯಾಕೆ derived to horizontal range. So horizontal distance ನಾವು ತಗೊಳ್ತಾ ಇರೋದ್ರಿಂದ horizontal component of velocity ನ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. So now let's see the distance x is equal to v into here. That is implies x is equal to the range of the projectile. That is the horizontal distance covered by the projectile from the initial position. That is r. That is equal to v means the horizontal component of velocity, that is v naught sin theta, that the time taken by the projectile to reach the ground from initial position, that is time of flight, that is tf. We know that the time of flight, so the time of flight is the time of ascent plus the time of descent, that is 2 sin 2 v naught sin theta divided by g. 2 v naught sin theta divided by g. That is the time of flight. Let's substitute it. Then r is equal to v naught sin theta. Time of flight is 2 v naught sin theta divided by g. Here see the horizontal component of velocity ತಗೊಂಡಿರೋದ್ರಿಂದ ನಾವು cos theta. So for vertical motion we have to take the vertical component of velocity. Here range irodrinda we have to take the horizontal component of velocity, that is v naught cos theta. Is v naught, this is sin theta, v naught cos theta. So in v naught there, v naught ಇದೆ. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, v naught square, v naught square. So 2 sin theta into cos theta divided by g. So we know that the trigonometric formulas. 2 sin theta cos theta. So 2 sin theta cos theta ನಾವು sin 2 theta ಅಂತ ಬರ್ಕೋಬಹುದು. 2 sin theta cos theta ನಾವು sin 2 theta ಅಂತ ಬರ್ಕೋಬಹುದು. Then range r is equal to v naught square 2 sin theta cos theta ನಾನು sin 2 theta divided by g. So this is the expression for the range of projectile. So r is equal to v naught square sin 2 theta divided by g. This is the range of the projectile. That means the horizontal distance covered by the projectile from the initial position. R is equal to v naught square sin 2 theta divided by g. Here see the time of flight is given by the first one is the time of flight. The formula Tf is equal to 2 v naught sin theta divided by g. This is the time of flight. And the second one formula is the maximum height of the projectile. The maximum height of the projectile that is h is equal to v naught square sine square theta divided by 2g. So this is the expression for the maximum height of the projectile. Then the third one, the range of the projectile. The range of the projectile. The range means the horizontal distance covered by the projectile from the initial position. That is r is equal to v naught square sine 2 theta divided by g. So this is the range of the projectile. So ಎಲ್ಲ formulas ನಮಗೆ problems ನ calculate ಮಾಡೋದಕ್ಕೆ use ಆಗುತ್ತೆ. Time of flight, height of the projectile and the range of the projectile. So now let's see the uniform circular motion. So uniform circular motion. So what is meant by uniform circular motion? So when a body is moving along the circumference of the circle with the constant speed is called a uniform circular motion. This is the circle. This is the circumference of the circle. So an object ಏನಾಗ್ತದೆ ಈ circumference of the circle ನಲ್ಲೇ move ಆಗ್ತಾ ಇದೆ with the constant speed. So that is called as the uniform circular motion. So this is an example for the two-dimensional motion. So two-dimensional motion example is the uniform circular motion. So what is meant by uniform circular motion? So the object is moving. The object is moving along the circumference of the circle. Circumference of the circle with the constant speed. With the constant speed is called uniform circular motion. Is called uniform circular motion. So object circumference of the circle ಅಲ್ಲಿ ಏನಾಗ್ತದೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅದನ್ನ ಯೂನಿಫಾರ್ಮ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. It is an example for two-dimensional motion. So let us discuss some definitions regarding with the uniform circular motion. That is, the first one is the angular displacement. Angular displacement. So now what is meant by angular displacement? See, the angular separation made by the body between the two positions is called the angular displacement. So see, this is the uniform circular motion. This is the radius of the circle. See, this is the initial position, this is the final position, this is an angle theta. So that is the angular displacement. So angular separation between the two positions. So now again normal linear displacement alli the shortest distance between the two positions ಅಂತ ಹೇಳ್ತಾವ ಅದೇ ರೀತಿ angular displacement. The angular separation made by the body between the two positions is called the angular displacement. So angular displacement means the angular separation made by the body between two positions is called angular displacement. Is called angular displacement. So, in figure, so this is the two position. Angular separation, adana ನಾವು angular displacement. So now the angular displacement is represented by theta. So angular displacement ನಾವು theta ಇಂದ represent ಮಾಡ್ತೀವಿ and it is represented by theta. And the unit of angular displacement is radian. So now angle na yavagu kuda ಏನು ಮಾಡ್ತೀವಿ radian ಇಂದ express ಮಾಡ್ತೀವಿ. The unit of angular displacement is radian. So this is the angular displacement, the angular separation between the two positions. It's called angular displacement and it is represented by the letter theta. And the unit of angular displacement is radian. Now let's see the second one, that is angular velocity. Angular velocity. So now what is meant by angular velocity? The rate of change of angular displacement is called angular velocity. So, angular displacement change ಆಗ್ತಿದೆ with respect to time. Position ಏನಾಗ್ತಿದೆ change ಆಗ್ತಾ ಇದೆ. So ಅದನ್ನ ನಾವು ಏನು ಮಾಡ್ತೀವಿ angular velocity. The rate of change of angular displacement is called angular velocity. Angular velocity. So that is given by angular velocity is equal to angular displacement by time. Angular displacement by time taken. So here the angular velocity is represented by letter omega. That is omega is equal to angular displacement is theta. Time taken is t. Omega is equal to theta divided by t. This is the angular velocity and unit of angular velocity. So here theta is the angular displacement, that is radian denominated in time. The unit is radian per second. Radian per second is the unit of angular displacement. So angular displacement ಆಯ್ತು, angular velocity ಆಯ್ತು. Next one is the angular acceleration. See the third one, angular acceleration. So angular acceleration is the rate of change of angular velocity is called angular acceleration. The rate of change of angular velocity. Angular velocity is called angular acceleration. That is change in velocity with respect to time. Change in angular velocity with respect to time. So then angular acceleration is equal to angular acceleration is equal to change in angular velocity by time taken. Then the angular acceleration is represented by the letter alpha, that is equal to change in velocity, that is omega 2 minus omega 2 is the final angular velocity, omega 1 is the initial angular velocity with respect to time. So this is the equation for the angular acceleration. The unit of angular acceleration is radian per second. So same as this linear velocity, linear displacement, linear velocity and linear acceleration. So in a circular motion, two-dimensional motion alli angular displacement, angular velocity and angular acceleration. Now let's see the relation between the linear velocity and the angular velocity. So what is the relation between the linear velocity and angular velocity? See, the relation between the linear velocity linear velocity and angular velocity. So 2 marks you can go there. What is the relation between the linear velocity and angular velocity? Now let us see. Here let us consider an object moving along the circumference of the circle with the constant radius r. So the object na todta idini. So that object is moving along the circumference of the circle. Then here see S be the arc of the circle. This is angle theta, r be the radius of the circle. So the object na todta idini. That object is in circular motion. That is the circumference of the circle with the constant radius r. See the figure here. AB is the arc of the circle. That is arc S. Nan arc na S anta represent madidini. Now radian na calculate madidini. That is theta. The theta is equal to, so arc of the circle divided by the radius of the circle. That is theta is equal to arc of the circle is S. Then divided by r. So now theta is equal to S divided by r. So ಇಲ್ಲಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದ the relation between the linear velocity and the angular velocity. Linear velocity is the rate of change of linear displacement by time taken. Angular velocity is the rate of change of angular displacement by time taken. Here see, r be the radius of the circle, then S be the arc of the circle, then theta is the angular displacement. Theta is the angular displacement. So now radian calculate ಮಾಡಿದಾಗ theta is equal to S divided by r plus the displacement ಬೇಕಾಗಿರೋದ್ರಿಂದ S is equal to theta into r. So now ಈ equation ಗೆ S is the arc of the circle, theta is the angular displacement, r is the radius of the circle. So ನಾನು ಏನು ಮಾಡ್ತೀನಿ, LHS ಮತ್ತು RHS ಅಲ್ಲಿ ನಾನು divided by the time t1 divided by the time t. So LHS ಅಲ್ಲೂ ಕೂಡ ಮತ್ತೆ RHS ಅಲ್ಲೂ ಕೂಡ ಏನು ಮಾಡ್ತೀನಿ, time ನ divide ಮಾಡಿ S divided by t, the displacement by time taken is the velocity, that is v. Linear displacement by time taken is v, that is equal to theta divided by t. Now again ನೋಡಿದ್ವಿ angular velocity is the theta divided by t, that is r into omega. So this is the relation between the linear velocity and the angular velocity. V is the linear velocity, omega is the angular velocity. So similarly, The relation between the linear acceleration and the angular acceleration is given by E is equal to R into alpha. So where A is the linear acceleration, alpha is the angular acceleration. So 2 marks ಗೆ question ಕೇಳ್ಬೋದು. What is the relation between the linear velocity and the angular velocity?